In this video, we will talk about solving problems using charts and graphs. There are 5 different types that we will be reviewing here. The first is a pie chart, then a line chart, bar charts, picture charts, and finally dot plots. Let's get to it. Here is an example of a pie, or sometimes called a circle chart. Let's take a look at what this chart is communicating to us. We read the title. It tells us that this is a sports camp weekly budget, and the budget amount is $2,250. That means the whole circle represents $2,250. The percentages around the circle tell us what different parts of the budget represent of that $2,250. Let's take a look at the kind of question that you might be asked about a chart like this. What percent does the camp spend on the 3 largest categories? In order to find the 3 largest categories, we're looking for the 3 largest pieces of the pie, so to speak. Those would be the bus costs, the equipment costs, and the lunches. We could also look at the percentage numbers and pick the 3 largest numbers, but we then want to add these together, and we can just add percentages to each other without converting them to a decimal first. And we're going to add those 3 numbers, and those add up to a total of 81%. So that would be the answer to that question. Let's take a look at another question that we could ask about the same chart. How much does the camp spend on umpires? Well, down here, it tells us that we spend 11% on umpires, and it's 11% of this amount. So using our percent shortcut, 11% of 2,250. We convert 11% to a decimal. That'd be 0.11. We convert of to multiplication, and this stays the same. We multiply that out, and you get 247.5. But remember that we're dealing with money, and we should always have 2 values after the decimal, so we add the 0 there. $247.50. Let's take a look at another chart type here. This is an example of a line chart, and line charts are usually used to communicate how something changes over time. Here we can see we have months of the year on the bottom. The topic of our line chart is the number of emergency room visits related to scooter injuries, and they're at a particular hospital, Westfield Hospital or Westside Hospital. Over here, we have the number of ER visits. So for charts like this, sometimes we are going to have to estimate what the values are. For instance, if we were trying to figure out what this amount is for November, we have to look at that and then try to figure out what that would be over here. So we might estimate that that is most of the way to 100 from 80. So maybe that's 95. We're not worried about whether we get that exactly right. Our estimates will be good enough to answer a question like this. All right, let's take a look at a question that could be asked about this chart. Which month had the largest number of visits? This is a pretty easy question to answer. We look for the highest point on the chart. That will give us our largest number of visits, and it appears like that might be about 105. But we're just interested in answering with the month of September. That had the largest number of visits. Next question. Which month had the largest increase in the number of visits? This is a little bit trickier because what we have to do is to look for the steepest line in this chart. That's the steepest line. If we were thinking of this as being riding your bike here, this would be the steepest part of a hill to ride your bike up. So we are pointing to the month that would have the largest increase in the number of visits, August. If we were looking for the largest decrease, we'd be looking for the steepest line going down and the month that that would be pointing to from going from left to right. Yeah, let's take a look at another chart type, a bar graph. Let's try to understand what's going on here. We have years going along the bottom from 2006 to 2011. We're talking about employee discrimination complaints, number per year. And this over here is the number of complaints. This is another example where we might have to do some estimating. We're going to look at how high the bar is, and then we will look over at the scale on the left and try to estimate what that value is. We will have to do that here in order to answer a couple of questions about how many more complaints were there in 2010 than in 2009. So let's estimate 2010 and 2009. Here's 2010 right here. How high is that? That looks like it's about right there. I'm going to estimate that that's 32 complaints. 2009, it appears that that was exactly 20 complaints. Then we just subtract the two. 32 minus 20, our answer would be 12. There were 12 more complaints in 2010 than in 2009. Next question, about how many complaints were there in 2007 and 2008? What that means is that we should add these two together, 2007 and 2008. Let's estimate. It appears like this 2007 might have been 27. And 2008 appears to be exactly 25. We add 27 and 25. 27 plus 25 is 52. There were 52 complaints between those 2 years. So sometimes you will have to add your estimates for the height of different bars. A picture chart. This is a little bit different. In a picture chart, a picture, in this case of a car, represents a number of cars. So a picture of a car doesn't mean one car, it means 50 cars. So what we have here is a Mayfair parking garage, daily average of parked cars by time period. We have between 8 a.m. and noon. We have from 12:01 to 4:30, and then we have from 4:31 to 8 p.m. And our picture tells us about how many cars were parked. Let's try to answer this question using that picture chart. How many cars parked in the garage from 8 a.m. till noon? So one way to deal with a picture chart where each picture represents 50 cars is to count by 50. This is 50. This is 100. This is 150. This is 200. This is 250. And now we have a half of a car. Well, half of a car must be 25 cars. So 250 plus 25 gives us our final count of cars for that time period. That would be 275 cars. Last chart type is called a dot plot. In a dot plot, each dot represents one of something. So let's take a look at the kind of information that's being communicated to us. The number of kilometers run by members of the running club. Number of kilometers run. This is 15 kilometers. This dot means that one person ran 15 kilometers. 3 people ran 14 kilometers. So it's a pretty simple chart. It's used to kind of tally up some results. Let's look at the question here. How many members ran 12 kilometers or more. An easy way to approach a problem like this is to circle that section. Maybe just in your head, circle it. But these are the ones that we want to count. And we just have to count how many dots there are. 1, 2, 3, 4, 5, 6, 7, 8, 9. There were 9 people who ran 12 kilometers or more. All right, that wraps it up for the different kind of graphs that we were going to talk about. Now it's time for some practice on your own.